Okay, next example is example 3. And this example, I'm going to be using on page 352 of your book, right? There's a yellow box called solving a linear equation, and I'm going to be following these steps, and I encourage you to use them to guide you as you're learning or reviewing these learning how to solve these linear equations. And this problem is very similar to example 2 in your book. It's not the same one, because I want to give you an opportunity to maybe attack the other one on your own, but this is very similar. So here's our algebraic or linear equation. And again, here's an algebraic expression, right? Again, a number is also an algebraic expression, right? I'm going to solve and check. What am I solving for? Well, x, because there's an x there. And again, I'm solving because I have an equal sign, right? So you can think of a little vertical bar here if you want, of your left-hand side and your right-hand side. Okay, so the first number one, the guidelines here are in your book again. It says simplify the algebraic expression on each side by removing grouping symbols, that is parentheses, brackets, and combining like terms. So that number one is really just the directions from our last session, right, in 6.1, and yeah, simplifying algebraic expressions. So we see parentheses, okay, and again, there's our algebraic expression, and I want to remove these grouping symbols. Well, I can remove them by utilizing, well, applying specifically the distributive property. So I'm going to distribute 6 to this and 6 to that term. So 6 times x, right? And I'm writing plus because there's really a plus out here. I mean, you can write a plus here if that helps. Plus 6 times negative 3. Okay, so I distributed. I haven't done anything with this minus 10x, so I'm just going to write it out. And then this 10, negative 10 on the right hand side is just kind of hanging out. There's nothing to do with it. It's just negative 10. Now, if you can go from here to the next step and you don't have to write this out, that's fine, as long as you are comfortable with it. Again, if this is on your test and you get the next step wrong and I don't see this part, I mean, again, it's very hard to give you partial credit if I can't read your mind. I have to actually see your work, what you're thinking. Okay, so distributive property, 6 times x is just 6x. 6 times negative 3 is minus 18. Minus 10x equals negative 10. Okay, so notice I have removed the parentheses, the grouping symbols. So in number 1, it says, well, simplify obviously the algebraic expression, but also combine any like terms, right? And usually you combine like terms right after you use the distributive property. So can I combine like terms? I sure can. 6x minus 10x. Well, 6x minus 10x is minus 4x. And then again, the negative 18 is just there. Okay, so combine like terms, check. So I'm done with number 1. Again, I'm referring to this yellow box or the yellow rectangle on page 352 of your book. Okay, number 2, collect all variable terms on one side and all the constants, right, or numerical terms on the other side. Okay, so collect all variable terms on one side. Well, my variable terms, right, it's this x, right, just negative 4x. It's on the left-hand side, so I'm going to keep it there. Why? Because I have a constant here. A constant is just a fancy name for a number. So here's negative 18. Here's negative 10. Okay, I can't combine like terms right now because they're not on the same side of the equation, right? One is on the left-hand side and one is on the right-hand side. So I am going to, and I'm going to use my blue here to emphasize my property of equality. So I'm going to add 18 to both sides. Okay, and then I'm going to write my vertical bar. So negative 4x just drops down. That's 0, right? if you owe $18 and you pay $18, your balance is 0. Equals, and then this is really just 18 minus 10, right? Or again, I want you to really understand this. Don't just punch it in the calculator. I mean, you can use this in real life. I mean, if you owe $10 on your bill, uh, and you pay $18, well, I mean, on your credit card, let's say, you have a credit of $8, right? 18 minus 10. Okay, so there's one step. And my variable terms, right, from our little guidelines here, right, my variable is on the left, my constant is on the right. So here you can ask yourself, if you want, -4 times what number is 8? Okay, and then you can say x equals that number, or if you're not sure, then I'm just writing this out. Well, this is -4 times x. What is the inverse operation of times x, or times -4? Well, I know I'm going to divide, right, or multiply by the reciprocal. So I'm going to divide by a number, but not just 4. I'm going to divide by -4. Why did I divide by -4? Well, because I want it to be 1x. Well, if I didn't, okay, so this is a negative divided by negative is a positive, right? And then 4 divided by 4 is 1. If I didn't divide by that negative, I would still have a -1 here, which is completely fine, but you just have an extra step. So equals, whoops, and then of course 8 divided by 4, right, or -2. So x is equal to -2. Okay, and let me actually go ahead and write, since we divided by -4, I just want to emphasize our multiplicative property of equality, right? That's what I really did. But of course, again, that was a negative, right? And then it changed to a positive. Okay, so let me, okay, so this is my claim, right? I claim that the solution, my claim, right, is that the solution is -2. Okay, well, now I want you to prove to me that in fact is a solution. And the nice thing about checking your solution is you know it's correct if you generate a true statement. So let's go ahead and check this guy. So it was our original, let's see, our equation. Oh, okay, it's way up here. So I will make this a little bit bigger, but I just wanted to make sure I have the right equation. When you check, you have to use the original equation. Okay, you cannot use any of these. It has to be the original one. So we have, whoops, 6 times the quantity x minus 3 minus 10x equals -10. Okay, and I claim that my solution set is -2. All right, well, again, I want to prove that the left-hand side is equal to the right-hand side, so let's substitute that -2 in. And I don't know, let's just make it, I'll make it pink just to emphasize. Okay, so I have, or did I use purple last time? I forget. It doesn't matter. I'm just trying to color code things here to hopefully the colors help. Okay, 6 times, what's x? Okay, -2 minus 3 minus 10 times what? -2 equals -10. Okay, I need that question mark there because you're determining if this is correct. So basically you're working with just this left-hand side, and you're going to, use the order of operations and hopefully generate a -10. If we do generate a -10, that means this is the correct answer. If we don't, that's okay. That means that, okay, I got to go back and I got to look at my work and I got to see where the error is. Okay, using the order of operations, can I do anything inside the parentheses? I sure can. right? You owe $2 and then you owe another $3, so you owe $5. Uh, Let me just go step by step here. Okay, I need to see every single step here. Okay, if you miss one step, if you don't write it, you're technically saying, if you don't write this part or this part, it just throws out, the equation is not going to be equal. Okay, so 6 times -5 is -30. Negative times negative is positive 20. Right, a little question mark there. And okay, here I owe $30 and I decide I only have 20 bucks in my account, so I can only pay $20. So what's my balance? Well, I still owe $10. So -10 equals -10, so that's a true statement, right? A false statement would be like 9 equals -10, right? So hence my singleton, my solution of -2, okay, you can say, so hence is a solution to, well, my equation above. So let's go ahead and write it out. Minus 10x equals -10, right? And again, we can also say -2, again, satisfies the equation, and then it's just the same guy, right? So I want you to be comfortable with the language because we are going to be using it quite a bit in this chapter and again as we go on. Okay, so this is the next example. Again, I know it was a little bit tedious, but I want to make sure that you know how to solve these equations correctly. Okay.